Okay, welcome to the fifth video. We're actually going to write a program and we're going to run it. So finally, first of all, we need to actually download the programming environment. That's something that we could write the program into, and then it will convert that program into machine code that the chip can actually understand. And it will also allow us to push that code into the Arduino. So I've already plugged the Arduino into my computer, and you can see that if I go to my control panel and I go to, it depends on where you are, Windows 8, Windows 7, whatever, but Device Manager, usually there's something like that on all versions of Windows. If I click on that, here's all the things attached to my computer. One of them, if you go to Ports and expand it, there's the Arduino right there. And you'll notice it says COM5, so that's a serial port number 5. Alright, so keep that in mind. And you know what, I just want to make sure the settings of this, yeah, just 9600. Actually, it doesn't really matter because this could be overridden. Never mind. So anyway, COM5, it shows up automatically, or you may have to install a driver when you plug it in for the first time, and it might ask you for permission. But anyway, yeah, just say yes, and there it goes. So that's hanging out there. So if you want to install it from scratch, if we haven't already installed it on your laptop, or you're doing this at home, then look up the word Win AVR. And you can see I've done this before. And let's go to the top link, download. That sounds good. And then you come to this site and it says the latest version is always over here. Fine, okay, we'll go over here. And this is where you download it. It's a 28 meg file. And go ahead and download and run it. And then what you actually end up having is, I installed it to the C drive. Let me go back up one here. So C drive, Win AVR. It asked if it could install there. I said no problem, go ahead. And that's what it did. So if you actually go inside there, this is what you see, a whole bunch of subfolders and some files in here. Notice one of the folders is PN. That stands for Programmer's Notepad. And if you go inside there, you can see pn.exe is one of the things you could run. Although, during the installation process, it probably should have added Programmer's Notepad to your Start menu. And so I can always go there by going up to Programmer's Notepad in Windows 8 and whatever. So one way or another, get Programmer's Notepad started. And I have a shortcut down here now, so I just run it here. And this is what it looks like. And it's essentially like Notepad, you know, just something that you could type text into, although it has some extra features that are very helpful for programmers. So one of the things I want to point out, though, is if you go to the Tools menu, notice you have some interesting options here. That have to do with Win AVR. So Win AVR, the program that we just installed, the 28 meg file, did a few different things. It's installed Programmer's Notepad for you and added some tools up here to make your life easier. And you can actually go to Tools Options and go to Tools here, and you can see the commands here. And what it's actually doing is each one's running this program called make.exe, which was also installed as part of the installation. And it's running make.exe with the all parameter or with the clean parameter or argument or program argument. So it's just running the same program with 3 different options next to it. And we'll talk about what that means. So what I'm now going to do is, oops, do I have the other? I'm going to go back to Hello World. So I've made a program, and essentially there are 2 files involved here. One is the program itself with a .c extension, which means it's a C file or C programming file, for whatever, C file. And the other one's called a make file, and this is what tells your computer how to compile it. I want to start there, so let me drag that in. It's just a text file, so we can edit it in this Notepad like anything else. And by the way, your screen may not look like this. The color scheme, if you go to Tools and Options, you can go to Styles. And down here in the presets, you can load different color schemes. So this is interesting. Actually, I kind of like that. Wombat. Let's stick with that for now. And the text is kind of small, so I can hold down the Control button on my keyboard and then scroll the mouse wheel back and forth to change. So you can kind of get a nice text size for you pretty quickly. All right. So, although you know what, it's hard to see this text. So let's. Let me go one more here. Style. I think let's go back to the one we had, which I think was solarized. Let's load that one. Okay, a little easier to read there. So first thing to point out is anything that starts with a pound sign doesn't mean anything. It's just a note that someone left for you to read, but it's nothing to do with the computer. The computer will ignore it. So this is just notes. But the first thing is MCU. This is where you define what CPU you're actually writing for, and so the compiler will make the right decisions for that chip. That needs to be set correctly, and that already is. That is the name of the AVR microcontroller that is built into the Arduino, so we're all set there. The other setting, this AVR Dude port, AVR Dude's kind of a funny name of a program that will communicate over that COM port and push your file into your chip using that bootloader we talked about in the previous video, but you don't really need to know too much about that. What you do need to make sure, though, is you may very well have a different COM port than what I have. I showed you I had COM 5, so I have 5 there. But if you had COM 6, then go ahead and change this number to a 6 or whatever it is to match what Windows is telling you it assigned that COM number for. All right. Those are generally the two things that really matter the most that you might get involved with. But just so you know, here's a part where you actually tell the computer what is the speed of that you're running your chip at, and it already comes pre-configured on the AVR on the Arduino to run at 16 megahertz, so 6 zeros. So that's all set up for you. And finally, what is the name of your file that with your code in it? And you remember it was main.c. right over there. So all you do is you give the name without the extension. That means without the .c, and what it does is it sticks the .c on it for you automatically later. So if you are going to change the name of your program from main to something else, then that's fine. Just make sure you change your make file to have the new name change. All right, that's enough of the make file for now. Let's actually bring in the program. So I'll drag that in as well. Notice I now have both files available. I can toggle between them really easily. And I'm going to control scroll to get a bigger character size. So the first thing I want to talk about here is this stuff up here. This also, just like we had on the make file, if anything started with a pound, it was ignored. Well, in a C file, if anything starts with / asterisk, and then ends with asterisk / anything inside that zone is ignored. So I'll make another one here. It doesn't have to be all stars. You can just say 1 star and put some stuff in, and then star / and you can see that, by the way, that there's some color going on here because it's a .c file. Programmer's Notepad realizes it's a C program, so it's automatically changed the scheme of this file for you to C, which means it's highlighting. It knows a lot about C, so it knows what words mean. It knows how to highlight it correctly for you. It's just a visual thing. It's very nice to have. So that's a note that I just described. If you want to put a lot of text in, like you got a whole paragraph to talk about, it's really simple just to put a / star and then write all your text that you want to do forever, and then at the end of it star / and there you go. You have a nice blocked out note, so it doesn't interfere with the program. It's just something there for you to read. And by the way, I really encourage you to add notes to your program. This is a pretty simple program, so maybe not so much here, but generally it's a good idea to write a lot of notes to yourself, so when you open up the file later, like 2 years later, it doesn't look like it was written by you just won't remember, trust me. You think you might remember exactly what you were doing, but you don't. So any notes you give to yourself in the future are good. I'm going to get rid of this text here. You can start a line, or anywhere in the line you can put / and anything you type after that is also ignored. And you can see I've done that down here with these notes. And what's cool is they can be on their own line, or you could stick it on the end. Oop, undo. Grab all this and stick it on the end of a line. And that still is, it just ignores anything from this stuff forward. So you can do it either way with this method of the /. I like to keep all my notes above the statement I'm talking about instead of to the right, but whatever your strategy is, go for it. All right, next thing. These include statements. What are these all about? Well, this is something we're going to gloss over at first, but we'll come back to later because it's kind of neat what's going on with these things. What's happening is we're telling the compiler, hey, before you go any more forward, I need you to bring in these files as well. And these files are located in that C:\Win AVR location. They're in the library file over there. And and it triggers, it basically is a neat way of, if you remember from the make file, there's you tell it the name of the processor. Well, that is kind of used inside these files to identify what DDRB means and port B means and all these other things. So you don't have to actually know where these values are in memory. You can just use these nice little ports, these descriptions. For example, if I actually, I'm going to do this on the fly. I wasn't planning on doing this, but I think I can do it here. I have this is the data sheet for the AVR microcontroller we're working with, and there's a lot to it. If I scroll near the end, though, you can see that there's a map of all the registers here, and it continues on and on and on, and eventually it gets to the point where it gets interesting. Like, for example, port B, which we will be using, is here. And it's actually located at this address. So instead of using port B, I could just simply say, at this address, do something. But that's kind of hard to remember. What does that mean? Instead, wouldn't it be nice just to say port B, and then it will automatically substitute 05 for you in its place and do whatever you need to do. We're not going to talk too much about it. So that's all I wanted to talk about, though, was that this stuff kind of allows you to do this sort of thing. To use regular names and stuff instead of having to use numbers of where memory locations are. And we'll get into a little bit more later. The delay is something I added, though. This allows me to run these delay commands down here, which is something that's very helpful, and we'll talk about that in a minute. All right, let's actually start, though. The code really begins here in the main function, and the main function starts with this open parentheses, or I don't know what you call that, and then closing one over here. So all the stuff inside here is inside the main function. In fact, you can kind of see that the programmer's notepad kind of shows you that, and I can even close it. Close this whole thing to get rid of that function, to collapse it. And what happens is you always need a main function in your program. No matter what the name of the program is, it always has a main function in there. And we're not going to talk about what this int means or what this void means yet. Just put it in there for now. And then start it with this and end it with this character. And that's all you need to do for now. So what I want to do, what this program is going to do, is blink an LED that is already on the Arduino. And I'm going to show you this. Here we go. So here's the diagram of the Arduino, and the light that I want to turn on is over here. It's this yellow light that's already on the board. It's there just for fun, just for you to control, and it's connected to PB5. Can you see that? It goes all the way across to PB5, and if you turn on PB5, you'll turn on that light. Another way to look at that is with the schematic. If I have it open still, here we go. This is the schematic that I was using in the previous video. The yellow light is right here. You can see this yellow light. It's attached to ground, which is 0 volts. So, and it's going the right direction. So if 5 volts comes through the arrow, then it's going to work. It actually has some resistors in front of it, which is good to limit the current. And then you can see it goes all the way to PB5. Can you see that? Let me zoom in a little bit. PB5 goes other places. It goes to a connector, and it goes to this connector, but those are just doing nothing. It also goes through the light if you want. So if I turn on PB5, if I put 5 volts on it, that'll turn on the light. So that's the idea here. So the first thing I want to do, though, is say I want PB5 to be an output so I can control it, instead of being an input where I don't really control it, I just listen to it. So I have to set it to be an output, and so I need to turn on the 5th bit inside DDRB. If you can imagine, I'm going to write a note here, DDRB maybe right now equals a binary 1, 2, 3, 4, 1, 2, 3, 4, so 8 bits, and then above it I'll write a note 0 or 7, 6, 5, 4, 3, 2, 1, 0. I want to turn on 0, 1, 2, 3, 4, 5. This one right here. And if I turn that into a 1, then that means that PB5, remember we're on port B now as in Bob, PB5 is an output. And all the rest, whatever they are, we don't need to worry about them. And so going from the Boolean, in fact, I'll do this for a second. Going from the lesson we learned about bit shifting and all that, in order to set any value to a 1, we use the OR equals, and then we take 1 and we push it over 5 times. So again, that means I'm actually doing something like this. I'm working against, let me make this a 0. And then if we do the math, then DDRB after this command becomes, well, 0B 001 0000. So I turn on the 5th bit, which means PB5 is now an output. Okay, so that's what this code does. We're going to have to get used to this idea that I want to get rid of this for now. I don't want to, that this is how I turn on the 5th bit. And this DDRB stands for data direction for this port, in this case B. If I wanted to change something on DDRA, or for port A, I would just be messing around with DDRA or B or C or D, whatever port I'm talking about. But because the circuit board is already made and PB5 is the one that's connected to the light, that's the one I need to mess with here. Alright, so this statement is done. It will turn on PB5 to be an output. Sorry, it doesn't turn it on, but it makes it available to me to turn on. And then I'm going to start a loop. And this is a little bit complex for the first time, but you can kind of probably get this here. Here's my note talking to the reader. And I say, while 2 is greater than 1, which always is the case, right? Run what's inside these brackets. So, in other words, we just made an infinite loop. It's just going to do this forever. And so what I'm going to do is turn on the light. So I actually, instead of talking to DDRB, I now talk to port B. That's the actual output register. If you write to it, it turns the pin on, assuming you've set it to be an output earlier. And I just say OR equals 1 to 5 over. So I'm turning on the 5th bit again. And that'll actually turn the light on. And then I could just go to the next line here where I do AND equals, where this turns it off, it sets it back to a 0 and go back and forth. But I wouldn't see much happening. I'd see the light kind of be dim because it would be essentially turning on and off just incredibly fast, by like 16 million times a second. So we wouldn't be seeing much. So we need to put a delay between turning it on and turning it off, and that's where this comes in. This function delay ms is available to me because I included this statement up here. There's a lot of basic libraries that you can include where someone's already done the work for you, has already run into a problem similar to this and solved it and said, hey, I'll make a library that does this very well, and they've done that. So I've included their library, and I'm running the function in that library, and I'm running it 1,000 times. I'm delaying this many milliseconds. So a millisecond is 1,000th of a second. So 1,000, this means I'm delaying 1 whole second. And then we go on to the next statement where on port B we turn off using the AND equals and then the inverse. And again, if any of this doesn't make sense, go back to that video, the Boolean math one, where we talk about how this works. Or you could just remember, turning on a bit means you do this, turning off a bit means you do that. Use this operation. So anyway, this turns the bit off, and then we wait, and then we go back to the beginning where we turn it on again, wait, turn it off again, wait, turn it on again, wait, and that's what happens. So I'm going to save my program because I've been messing around with it a little bit, and I'm going to go to Tools, and I'm going to say Make All, and I'm going to keep this. You go to Personal Arduino, Hello World. So here's my program. Here's the 2 files right now, and I'm going to say Make All, and watch what happens during the process. A whole bunch of new files show up, and there's even a subfolder, and inside there is something weird. These are all parts of the compiling process. It makes a object file, and then it links them to. It gets a little complicated, but the end result is you have this hex file, and this hex file, if you open it, it looks kind of weird. This is what it looks like. This is all your code that you made here in English, essentially semi-English, if you will. Actually turns into this kind of gibberish, and it's now ready to be put into your chip. So that's what the compiler does. It turns this into this. So now what we actually want to do is we want to send that over. In fact, you can see if I raise this up, here's the output down here. If I had an error in my program, let's say I had a typo. Let me get rid of this I. Now that's an error. Doesn't make any sense. Yeah, I'm going to say compile and watch what happens, or make all, which is compile. Oop, it says warning in C16, which we are at 16. Implicit declaration of function. Well, what that's really telling you is hey, you want to do something here, but I don't know what this is. This doesn't make any sense. So I I can't go forward. So exit code 2, that means it wasn't able to complete the process. So I'll fix the bug, and then I'll rerun make all, and you can see it goes right on through. It even tells you how many bytes the program is, which is very little. You're only using 0.5% of the ability of this chip, so there's a lot of room to add. However, I haven't moved it to the Arduino yet. The next thing would be to go Tools, Program, and you can see, because mine's plugged in, it's so fast because it's such a small program, but it actually wrote to it and it even read it back to make sure it was written correctly, so it verified the chip. And unfortunately, you can't see in the video here because I'm doing a screen capture, but I'm holding the Arduino in front of me and I am looking at a blinking yellow light. On, off, on, off. So it's working. And you can make it faster by bringing the delay down some, and then you can actually say program, and what it'll do is it'll compile and program it into the Arduino at the same one after the other. So here's the compilation, and then the writing to the Arduino. It did both, and now actually it's not. Oh, I have to hit save. Notice the little asterisk right here? That means I haven't hit save yet. So once I hit save, now I can do my make program, and now my orange light or yellow light's blinking much faster. Okay, so that's really all I want to, I think this is a good start. The other thing is, notice we have all these extra files that were part of the, the process of compiling. I can say make clean and watch what happens to those files. They go away. So it gets rid of all the temporary files and you have a fresh, it goes back to your fresh start. And then if I say make all again, those files will come back. There they are. And then make program pushes it into your Arduino. So that's pretty easy. All right, so here's a good starting point. I will put these files on the website somewhere. I haven't figured out exactly how I'm going to do this yet, but we'll get there. And then we'll do this in class, and then we can do some other things as well. But this is our starting point. Okay, you know what? One tiny thing. I want to show you this file, this LS. Is it LSS? Let me see. Yeah. This file here is interesting because it kind of shows you it converting your code into assembly code. You may have heard of assembly code. Assembly code is very low level. It's like essentially writing a machine code almost. You're almost writing in this kind of code, but not quite. Anyway, it's converting this sentence that we wrote into these actual instructions, which is pretty neat. So you can actually see it's loading into register 5, for example, and if you look at my little chart, you can see register 5 is port B. So it's converted port B into, it knows that actually means register 5, so it's done that substitution for us, and then it writes in the appropriate value. So you can kind of take a look in here, and here it is. Here's the other one, and so these are all assembly code instructions. I used to know a lot more about that than I do now, but I'm so addicted to just staying in C, I don't have to know assembly anymore much, but it's a good thing to learn. Maybe we'll get into that at some point. All right, I think that's enough for now. At the next class, we'll be doing this. Hopefully you guys have, some of you guys have bought Arduinos, so we can actually share, or everyone can have their own, or almost their own, so, and hopefully get your laptops up and running. So this is the first step, and it only gets cooler from here. I'll see you guys later.